Hello everyone. So today we'll be discussing about the prompt engineering. Basically, prompt engineering is something that's an essential part of this large language model days, including ChatGPT, Claude, Llama, or many more models. It's all about the prompt engineering. So what is actually a prompt engineering? In a very simple language, prompt engineering is a native language of interaction with large language models. So if you want to communicate with large language models, it and you want it to serve certain purpose, so you need to communicate with the large language models on the same way. And that actually defines everything that how successful your communication and output will be. So it has multiple parts. As you can see, the first part is the prompt engineering. Actually, it's a way of inputting the requirements you have in a very convincing manner. The way you are going to present it or the inputs, which could be termed as a prompt, significantly influence the quality, relevance, and accuracy of the model's output. So it's a very crucial skill that's required to communicate with large language models. Now, preparing or creating a standard large language model takes a toll of reading and learning about it. One of the basic things of large language model depends on the communications which will define by prompt engineering the maximizing the efficiency of the informations or the requirements that's been fulfilled by the large language model. It enhances the output quality from there and also facilitate the specific outcome from the large language models. This will sound a little bit different, but when we go through this entire tutorial, you will understand that's why and how it plays a very crucial role in terms of this large language model era or generative AI era. So let's go through the, the overview of large language model. So large language models are developed in multiple ways. One of the major ways is using the deep learning techniques, particularly using a neural networks. A network like GPT, ChatGPT's GPTs 4, it's built up upon the transformer structures or the transformer architecture, that would be better term. Then it comes to its capability. The capability of this GPT-4 right now is it can listen, it can read, it can generate like text completion, translation, summarization, answering your question, and as well as writing code for you, generating graphs. This is a miraculous advancement we have got in last couple of years. Then we have the general use cases like chatbots are content creation, language translation, research assistance. You can look through my channel, YouTube channel, you will see the research paper writing a lot of other components which can be useful in your regular life is in there. So what's the role of this specific prompts? So the role of the prompts are quite, I would say, specific. First is input interpretation. So this interpretations is kind of the way the large language model was already trained. Then guide the model, like how well structured your model was, your prompt is. Based on that, the model will be responding, certainly based on the training it had. And balancing openness and specificity. That is a kind of a very important thing, because if you are precise and specific what you want, the model can respond better. That's the idea. So then comes to the question, what are the theoretical foundation for this large language models? So this is a kind of a basics are, I would say, neural network. A neural network has two parts probably in here, like in here I am divided into two parts. It's like architecture in large language model. It could be the transformer-based model. So the core of the architectures of like GPT-4 is transformer model, and it simultaneously process the data. So the transformer architecture processes the data, and then it has certain layers inside it. These multiple layers have the subcomponents like multi-head, self-attention mechanisms, and which is a fully connected neural network. So these models comprise together, and they process your input. Then it has these specific nodes and a weight. So nodes are kind of a neurons, and each of these neurons represent as a computational unit which is specifically process the input data. Then the weight is something that's kind of a parameteristic during the training in the neural network, and that defines the input data how is processed throughout the network. So these are part of the pre-training, and these are the structures way. Then if you go to the role in processing unit, then it has two parts. One part is sequential processing, and the second part is transformation of unit. If you go to the sequential processing in there, it means that when you put an input, it takes the data step by step, the input, the prompts, and process it in a kind of a sequence and refine it at each level, at the complexity. For example, if you're writing the sky is blue, it will process sky, then is, and blue, and then make sense out of it. Then the next part, as you say, the transformation of unit. So when it processes this data together, like one by one as a sequence, and then at the end of the day, All these layers come together, and the final layer, the output becomes a model response. That's the basics, how the neural networks works in there. It's like our neurons in our body. If you go to the neuron and if you see the structure of neuron and how they sense in different layers of our brain, different parts of our brain, the frontal lobe to the different parts, it's kind of like that. It's people are trying to copy it at some extent, and the design is mostly motivated by that. Okay, then how the LLM is working. It has two parts in there also. One is processing prompts, another is embedding. Sorry, or the processing prompts is two part. One is tokenization, another is embedding, and the last part will be the sequence modeling. Then we will have the attention mechanism. So if the first we go through this processing prompts, then if we say it says blue, you probably is giving it as a whole sentence, but the LLM is not taking it as a whole sentence. It is taking sky as one token, is another token, and blue as a separate token, so that model can understand it better. Then comes to the portion of embedding. So each token is transformed into a numerical vector. And then those vectors or the embeddings kind of come throughout a sequence, get modeled based on your input, and generate a coherent and contextual relevant text. That's the processing mechanism of a prompt. Then the second part we have is attention mechanism. So the attention mechanism works on two ways. One is key component, another is self-attention. In the key component part is a transformer model key component, where it weighs the different parts of your input text importance. And the self-attention part, it goes to the entire input sequence, each part or each token, and lead to a more context-aware generation of text, which makes sense to you. Now, the question is, what is the mathematical principle behind that? There are multiple methods on the market. Probabilistic modeling in LLMs is one of the very important one. So what it does in there? So LLM can predict the likelihood of the possible next word in sequence by using the probabilistic modeling based on your input prompt. And the next part is softmax function, ledgers, and temperature. So softmax function is when you give a specific input, the softmax function convert it to the probabilistic distributions to a possible output word. And logits is an output from the final layer of neural network. Simply means that's preliminary prediction of the model. And the temperature Temperature is kind of a probability distribution is defining on a different way. Like if the higher temperature in there, that creates a more randomness. And if the temperature is lower, reduce the temper. It reduces the randomness in the prediction model. Then comes the engineering aspect of your prompt engineering. So it has also like prompt types and formats. So these are different types of prompts you could probably have. If you have a like open-ended prompts, for example. So what does it mean? It's a broad input you have provided in there. And it will like it's perfect for brainstorming, storytelling, or some sort of generating ideas. In terms of if you are going for a specific question, they are focused. And if you are providing an instructional prompt, okay, do it, write this code, find the error within this code, then it will work specifically on that way. Then formatting for different outcomes is another different part. Like if you want prompt to be a creative, you play with your temperature and topping. If you want a factual information, you give it a concise prompt. If you want a code generation, you write it down. Okay, you generate this is I have this data and you choose the Python, pandas, Seaborn to generate this bar plot. That could be better specific. Now, if we come to the parameters influencing the LLM or large language model response, so there are multiple parameters, and this is very important from the prompt engineering. That most of the previous work is done by the designers or the company who generated this model, but this one is little bit tricky. So here you have two parts. One is exploration of parameter, and another is modifying model behavior. This is very critical. The first part, the parameters within that exploration of parameter, it has, let's divide it into two parts. One is temperature and another is top P. So as we discussed earlier, the adjustment of the temperature actually define what will be the response from the model. If the temperature is higher, it will increase the creativity, randomness, and variability of the response. If the temperature is lower, it is more predictable and safer response, or moreover a consistent response. Now the second part is top P, which is known also as the nucleus sampling. So this parameter controls the diversity of the model's response. For example, you set for top P2 or 1.5. So it will consider wide range of words to be considered. Therefore, increase the variability of the output. But if you are setting the lower P, top P, then you have more of a limited variability in terms of output. Now, if you want to go to the model behavior and you want to modify it, so what do? You have to play multiple ways. You need to work on creative task, temperatures, top P, the way of accuracy, the information you put in, the precision of your information, a lot of parameter in there. We'll be discussing those later on. So next part is what's the best practice in prompt engineering then? So we have two part of it. First is designing the effective prompt. That's the crucial part. Take the entire LLM as a teenage and guide him or her towards this entire process. So the your prompt need to be effective by having specificity, clarity, and context specific or context inclusion. And the second part, you need to keep a balance in between the specificity and openness. Like if you want model to think and also be specific on your demand, then write it in such a balanced way so that it's not becoming so constrained and simultaneously producing a good amount of thoughtful or convincing output. So if you want to go a step by step on like how to do the prompt engineering, it would be something like setting the objective first. What do you want this model to do? The LLM, what are the specific question or problem, the information you are asking it to do? Then craft your prompt, construct it in such a way that it sounds like a convincing specificity and provide some example so that it can understand what actually you are asking. Then you go for the fine tuning of parameter. Okay, I'm very specific to it. So I set up the temperature and top pay accordingly. Or I am very much open to the idea, okay, what the hell it comes, it doesn't matter. I want it to be with the brainstorming around the across the world. So you set up the temperature and top pitch so high. Then iterative refinement is another one. Like you get some output and then you give a feedback and say, okay, that's kind of a refinement system that you have in the machine learning. Like you say, okay, this is not right. I want you to improve a little bit more. That's how you do it. Then, if you are going the next level, advanced topics in prompt engineering, then you need to go like the chain of thought prompts, like to structure step by step of your prompt, having a reasoning, particular problem solving task, and give it step by step, like a small part by part problem so that it can understand it better. Then you can show like what is the application, show, give an example, and it will understand. The next thing is that zero shot and few shot learning. This is very important. The zero shot and few shot learning is really crucial. The zero shot one is something like for example, this large language model for maybe ChatGPT. It was not trained on certain matter. Take the medical science. It was not trained on that. And you give it some sort of patient data. You ask it to solve it or find the disease. This is a zero shot learning. It will do it general understanding without a specialized training. And you can do the few shot learning. That's the model is trained a little bit on that. It's a kind of a small training or mini training, like the boot camp you do for a week, and you think you are expert on that, which we're not. Hmm. So, and then model generates some sort of understanding, but not that convincing as an expert level. But you can do the strategic also in the end. Like when you are providing something, you assume that okay, machine is not trained on that. So then you can give the strategic, effective, sequence-based, very precise, crafted prompt so that the machine from the general understanding or the very small training also can actually think and make a convincing output from there. So next part is ethical consideration. So when this is very important, like the machine could be biased towards the training data it had. So actually ask it to be very careful, like avoiding the stereotypical, discriminatory language or something like that. And ask it to be responsible. Okay, do it responsibly. Don't just generate something that would be an ass. Don't do something that doesn't fall under the category of good behavior and ethical, and train it accordingly. Put a precise instruction in there. That's how we do it. So this is overall training. Now let's see, like a couple of things. I will go through a few examples to show you like what is that. So we talked about the temperature and topic. Let's see. Open AI playground. We try to enter in there. Okay, I could be wrong. So just go to the chat. You can see this is the temperature setup. You can set up from 0 to 2. You can set up the maximum length of the text response, copy that nucleus sampling. You can play with these frequency penalty, presence penalty. There are lots of things you can do. And you can ask the machine to do it. Now, we'll sign into the ChatGPT and we'll try a couple of examples with different range of, like, let's play at the very beginning with the temperature and top P and see how the machine responds. So we go in here and we just write who is going to be the next global power. Keep them 0, top P 0. So the differences in between their responses. Okay, let's try now. Temperature one. See, the way of it's written, predicting will probably involves various factors, and there's a very decent and consistent writing. In here, speculative, and you see it's writing a completely different way. Here you had the countries China, India, United States is not even mentioned. Okay, other nations. Okay, in here China, Russia, China, India, European Union, United States. It's a different way of responding. So this made a difference in terms of the. Let's ask question now. Asking it, so as you can see in here, it's the response was grounded in current global dynamics and widely accepted manner. In here, despite the hypothetical changes parameter, the response met a factual analytical approach consistent with the first response, which is a very good thing, but still it made a quite a difference in terms of the responses, as you can see. So this is how it works. Now, let's go to the new chat and let's see how the responses actually by using the different parameter makes a difference. Let's ask a question. Assume, let's assume first that we ask a simple question. Never take any medicine from any online suggestions. Go to the doctor. I'm just asking. That's our first response. Now let's write. Let's see. See, highly suggestive of COVID-19. This is how you need to write a prompt. Here, nothing. Here, you have a different part. You give it a role, then you give it what it does, then you define that it should have the kind of knowledge, then you describe your symptoms and asked it specifically what to do and asked it to keep the temperature and top P at 0. And it gave a very precise answer. This could be the symptom of COVID-19. So that is the basic and the idea of this entire prompt engineering. And that's how you should interact with large language models. That makes the difference. It could be as effective as it is, or it could be worthless. Like what the counter get that citomycin, ibuprofen, you can get it for hundreds of disease. So this is something is like it's highly suggestive of COVID-19, and that's the success of it. Or you ask it to write a specific code or anything, it will do very specifically like this. You can use the ChatGPT, you can use the Claude, you can do the Llama, you can use uh, any other. And if you know the prompt engineering, you can write a precise prompt. You will use it. You can use it as a assistant of yours. It will do everything you ask. Generate the data, make the output what you actually require. Otherwise, it's just worthless use of things, nothing else. So that's all. With this, I end up today's discussion. Have a nice day.